Namaste, good morning. This is Professor S.lal, Professor of Mathematics and Computing under the Department of Science and Technology in the Faculty of Education and Methodology of Jayoti Vidyapith Women's University, Jaipur. Students, I hope you are fine and you are enjoying your study. I hope you have gone through your even semester curriculum of fourth semester. And in fourth semester of B.TECH Computer Science, there is a very interesting subject for you. A very interesting course is for you. And that's name is optimization technique. And it is expected that during your service in any industry or in any organization, either in India or in abroad, you are the person from which anyone can expect that you have knowledge that how to optimize any problem, any solution. So you can say that if such is the case and such is the importance of optimization technique, then what is the course outcome of this subject? First of all, what is optimization technique? I would like to discuss with you. Then I will try to share some PPTs in the support of your understanding or in my lecture. First is what is optimization technique? Second, what are the outcomes of optimization technique? Means what is the feasible range? What is the practical output? Means how this subject, how this course is going to give you, practical exposures during your working in the industry. So it is well known fact that optimization technique is such a technique in engineering where we connect the situation with the industry. And in any business venture or in any business organization, the one point target is to get benefit, to minimize the cost and to maximize the benefit. So such a branch of computational mathematics in which we deals with the facts that how to minimize the cost and maximize the benefit. And for that, there are different algorithms. For that, there are different platforms, different corollaries. This concept is going to play very vital role in future. So I hope it is clear that what is optimization technique. Now I am coming to the point in this introductory lecture of optimization technique. I am coming to the point that what is the course outcomes. Means if you have learned, if you have studied optimization technique in the class, then how you are going to be benefited. You can learn the skill. The first outcome is what? A learner can learn the skill to optimize the problem or optimize any situation. Optimize means result as per your need, result as per your choice. Sometimes you want to minimize, sometimes you want to maximize. Suppose a patient is, suffering from fever, high fever, cutting cold. Then the optimization technique that is used by the villagers is what? They are not doctors, they are not, medically sound, and they are not educated medically. But what technique they apply? They wait, some pieces of cloths in water, and they put that weight a portion of cloth on the head of a person who is suffering from fever, or they wash the body with the, that very cloth that is, bearing, different drops of waters. The target is what? To minimize the temperature. Similarly, in winter season, poor people, how they arrange to maximize the heat of their body or the surrounding. There are different optimization technique they use. In the industry, the like scenario is that the manager or the, promoter of the industry always try to get maximum benefit by using minimum resources. Or another aspect is that by how many ways a single instrument is going to be used in the different works. See, this is the mobile. This mobile has different features. It is working as a clock. It is working as a radio. It is working as a TV. It is working as a computer. It is working as a telephone. It is working as a camera. So this simple or single instrument has different applications. It is why all the, configuration, process, accessories, they have been optimized as per the need of the stakeholders, as per the need of the customers, as per the need of the users. In the live scenario in the industry, it is expected by a computer engineering expert or by a software developer or any developer or any network administrator or any XYZ person who is working in the industry, that whether he or she has knowledge to optimize the situation, optimize the problem or not. So this, a specific segment of your B.TECH Computer Science fourth semester is going to play a vital role in your not only enhancing the knowledge level, but promoting the skill. So this is the, in nutshell, this is the course outcome. Means by learning this, you can learn by going through the optimization technique, by the study of optimization technique. It is possible for you to learn the process of optimization of any numerical problem, any industry problem, any problem that is going to affect the society or industry or uh, mass of stakeholders. So I hope this is the prima facie introduction, and now I am going to share some facts related to this optimization and this optimization technique. So You see, just give me 1 minute. I discuss with you about optimization technique. So uh, I hope this screen is visible to you, and you are suggested to note that optimization problems means problems which are dealing with the optimization technique are, or they are based on the optimization technique or optimization problems. So it has classification, means optimization problems may be classified. So the first classification you see in the left, this is continuous optimization. And the second is optimization under uncertainty. So in continuous optimization means what, and discrete optimization means what? As per my knowledge, in continuous optimization, there is no any constraint for choosing the variables. It may be large and large and large, not 3, 4, 5, 6. It may be lakhs, 3 lakh, 4 lakh, 5 lakhs. There is no any such constraint. But in case of discrete, there is a limitation that how many variables we are going to take to justify the region, or to deal with the justification, as we are planning to say. So you see here, in continuous optimization, here is unconstrained optimization, bound constraint optimization, derivative free optimization, global optimization, and you see here, this is highlighted linear programming. You have gone through at your 12th level. Network flow problems, non-difference optimization, non-linear programming. You have also seen this. Optimization of dynamic systems, quadratic constraint, quadratic programming, quadratic programming, second order cone programming. These are some specific type of continuous optimization. And optimization under uncertainty consist robust optimization, stochastic programming, simulation or noisy optimization, stochastic algorithms, and it has also one specific segment, that is complementary constraints and variational inequalities. Under this, we can see complementary constraints, game theory, linear complementary problems, mathematical programs with complementary constraints, non-linear complementarity. So you see here, as I told you, after continuous there is a discrete and integer optimization. So I have already told you what is difference between continuous and what is difference between discrete, and I hope that you are already aware about a continuous variable and discrete variable. So in the same segment or in the same logic, you can explain the fact and you can try to understand. So discrete and integer optimization, this is combinatorial optimization, traveling salesman problems, integer programming, mixed integer linear programming, mixed integer non-linear programming. These are the discrete and integer programming, and I hope we have already discussed about this. And you should note down that there are some system equations sometimes in campus placement and some other activities, in your interview when you apply for job in any industry, or you move hither and thither, or if you are discussing with any experts related to your industry, or you are talking about something that is relating to your work that needs to be optimization, then they used to discuss that. Have you listened the term system of equations? Then you should say yes, yes sir, yes, yes ma'am. I have listened data fitting, robust estimation, data fitting. It has another name also, that is robust estimation. Then the nonlinear equation, then nonlinear least squares. Then the person will be happy. Yes, means system of equations has been categorized further, has been divided further into three different categories. The first one is data fitting or robust estimation. The second one is nonlinear equations. And the third is nonlinear least squares. So the next topic that is very good for you to understand, that is system of inequalities, multi-objective optimization. So I hope that inequality term is known to you, and if you see something like that, less than or equal to or less than or greater than, though that is saying that that is sign of inequality. In optimization problems, we also uh, have to see. So after this prima facie classification of optimization problems as continuous and others, it is time to come on the very important topic, convex function. In your physics, recall, during your ninth or 10th or 11th or 12th, there was a term concave mirror and convex mirror, concave lens and convex lens. So it is a matter of happiness that is it possible to say any function is convex, convex like this is convex, this part is concave and this is convex. Convex means some part is like this, some part is indicating toward the upward direction, and there is no any such depth as depth is here. So you see the uh, glass, or you see the other mirror, some are plane, some are concave, some are convex. So convex function is what? Definition is very clear and it is very intuitive for you. You see here, a function fx is convex in an interval if it is if its second derivative is positive on that interval. Means if you are differentiating a function, suppose there is a function y is equal to fx or simple fx, you are finding first derivative, then you can write it as f dash x, means dy dx of fx, you are writing f dash x. Again you are differentiating. It is not going to be vanished. Definitely this function is not less than second degree function. Means at least this function is quadratic, because if you, I am giving you example, if there is a function x, if you are getting its first derivative, then its value will be what? Dx by dx is equal to 1. Again you are differentiating, it will be 0. So in nutshell you can say that at least minimum first degree or second degree, it is good. But the function is, if the function is constant, in that circumstance, in the first strike, means the first derivative at least will be 0. So a function fx is convex in an interval if its second derivative is positive on that interval. And just I told you, you can see here this function is x square, and its first derivative is this, and second derivative is this. So this is the differentiation of 2x is what? 2, and 2 is greater than 0. So it is at least positive. So this will be what? This is enough. So I hope this is the end of today's introductory lecture. And in the next class we shall discuss about other aspect of this topic. So thank you very much for listening and enjoying this lecture.